Have you ever stopped to think about what would actually happen if all the ice on our planet just disappeared? I know, it sounds like something out of a disaster movie, right? But the thing is, the melting of our polar ice caps and massive glaciers, it's already happening. And it's kicking off this huge chain reaction, a kind of global domino effect that reaches way, way beyond the frozen poles. So, let's dive in and see how this all plays out. All right, so let's start with that one big, almost unthinkable question. What if the world's giant ice shields, we're talking about places like Greenland and Antarctica, what if they just weren't there anymore? It's a pretty dramatic thought, I know, but asking it helps us wrap our heads around the enormous scale of what we're really talking about here. Because, it's easy to think this is just a problem for polar bears on distant ice floes, but the stakes are incredibly high for every single one of us. We're talking about the safety of our biggest coastal cities, the stability of the fresh water we drink, the balance of entire ecosystems getting thrown way out of whack, and just massive, massive disruptions to our economies. So yeah, this is way more than just a polar problem.
Okay, so to really understand what happens when they melt, we first have to get a handle on what these ice shields do in the first place. You see, they're so much more than just giant chunks of frozen water. They are, in fact, some of the most important climate regulators on the entire planet. Now, the official scientific term for all this frozen stuff is the cryosphere. And honestly, you can kind of think of it as Earth's built-in air conditioning system and its emergency water tank, all rolled into one. It includes everything you see here, the big ice sheets, glaciers, sea ice, even permafrost and snow. And the really critical thing to remember, this is all frozen fresh water, a massive, massive reservoir of it. So what's causing this whole system to go haywire? What's pushing that first domino over? Well, the science is really clear on this one. The cryosphere is shrinking. And not only is it shrinking, the pace of that melting is actually speeding up. So let's look at what's behind it. The primary driver, according to the IPCC, that's the Intergovernmental Panel on Climate Change, basically the world's top authority on climate science, is global warming. And it's really like a two-pronged attack. You've got warmer air melting the ice from above, and at the same time, you've got warmer oceans melting it from below. It's getting hit from both sides. And the most direct, the most talked about consequence of all this melting is, of course, sea level rise. This is the first and probably the most obvious domino to fall, and its effects are already being measured all around the globe. Now, here is a really, really important distinction to understand. Think about it like a glass of water with ice in it. The sea ice you see here, that's like an ice cube that's already floating in your glass. When it melts, the water level doesn't really budge, right? But the land ice, from glaciers and ice sheets, that's like adding new ice cubes to an already full glass. That new water has to go somewhere, and that's what makes the sea level rise. And this chart breaks it down perfectly. It's actually not just about melting ice. Look at this. For this period, about half of all sea level rise came from something called thermal expansion. It's simple physics, really. As the ocean gets warmer, the water itself literally expands. It takes up more space. The other half came from all that new meltwater pouring in from land, mostly from glaciers and those huge ice sheets in Greenland and Antarctica. So to really put this into perspective, to understand the sheer volume of water we're dealing with, if the ice sheets of Greenland and Antarctica were to melt completely, they hold enough water to raise the global sea level by a staggering 65 meters. That's about 213 feet. Now, that's a very long-term scenario, but it just shows you the mind-boggling amount of water that's currently locked up in ice. But here's the thing. Sea level rise is just the beginning. The melting of the cryosphere sets off this whole cascade of other impacts that are literally going to reshape our world. Think about it. When you dump all this cold, fresh water into the salty ocean, it can mess with major ocean currents. And these currents are like the planet's conveyor belts, moving heat all around the globe. You disrupt them, and you could get totally unpredictable changes in weather patterns thousands of miles away. And at the same time, we're seeing this massive reshuffling of life in the sea. Marine life is on the move trying to find cooler water, and animals that are adapted to the cold, well, they're quickly running out of places to go. So let's bring it back home. What does all of this actually mean for us, for human society? This isn't some abstract problem for the future. We're already living with the consequences right now. Experts have a term for this. They call sea level rise a threat multiplier. And this graphic here shows you exactly why. Rising seas don't happen in a vacuum, right? You've still got your regular tides, you have storm surges, and in some places, the land itself is sinking. A higher sea level just gives everything else a head start. It makes every single one of those other threats that much worse. A regular storm can suddenly cause major flooding. A major storm can become, well, catastrophic. And we can actually see this happening in the data. Just take a look at Charleston, South Carolina. Back in the year 2000, what they call nuisance flooding, that's basically just sunny day high tide flooding, it happened maybe once or twice a year. Fast forward to 2020, and it was happening 5 to 10 times a year. That's what just a few inches of sea level rise can do. It turns a rare events into a regular headache. And this, right here, is the real-world human cost. We're talking about salt water seeping into the freshwater wells that people rely on for drinking. We're talking about critical infrastructure, our ports, our roads, our power plants being put at risk. And ultimately, this all threatens food security, people's jobs, and the basic safety of tens of millions of people who live along our coasts.
And I want to leave you with this really powerful statement from the IPCC. They say that these changes are, for all practical purposes, irreversible on a human timescale. Think about that. Even if we stopped all emissions tomorrow, it would take thousands and thousands of years for these massive ice sheets to grow back. It's a pretty sobering reminder that the choices we make today are locking in a future for countless generations to come. That first domino is already tipped over. The real question now is, what do we do before the rest of them fall?